Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 6, Permutations, Combinations, and Binomial Expansion, brought to you by Vitan Sir. Previously, we completed the exercise 6.1 of the permutation, and we understood the concept of permutation and practiced many sums based on that. This time I am going to start with the second topic, that is combination. Now, let's start with an example. There are three friends R, G, B. I think you are familiar with this. Yes. Now, the scenario is different. They are appearing for an interview for two vacant posts. That means three friends are going for an interview in which two posts are vacant. That means only two out of these three friends will be selected. So in how many ways can we select two out of three people? Now, if we talk about permutation, we know that if we are selecting two out of three people, how can we select them? We can select R and G, or we can select G and R. We can select RB, or we can select BR, and we can select GB, or we can select BG. But you know what? If I'm selecting people, it doesn't matter whether I select the red first and then after green, or I select green first and after red. That means if I select first R and then G, or if I select first G and then R, it doesn't matter. That means these are not two options. This is just single option, selecting red and green. It doesn't matter who is selected first. That means the order in this doesn't matter. Similarly, it doesn't matter whether I select red first and then I select blue, or whether I select blue first and then I select red. That means this is again a same, this is again a one option. And lastly, this is also a single option. That means it doesn't matter whether I select green first or whether I select blue first. So the selection, the order of selection doesn't matter. We are not arranging people, right? We are selecting people. So when we select people, the order of selection, the method of selection, who is selected first, who is selected afterwards, doesn't matter. So rather than six, we only have three ways of selecting two people out of three people. What if we have R, G, B, and we have to select all three? Okay, the company liked all three of the friends and then decided, okay, whatever, let's select all three of them. Doesn't matter how many posts are there. So then, in how many ways can we select three people out of three people? Now, if it would have been permutation, it would have been something like this. Okay, these are the various arrangements which are possible, but this is not permutation. Okay, we are selecting people and order doesn't matter. That means it doesn't matter whether they are RGB, or they are GBR, or they are BGR or BRG. We are selecting three people, so all of these are same, and because all of these are same, all of this is just one. And therefore, if we are selecting three people out of three people, the method of selection are not six but just one. We are selecting all of them, so we are only going to be able to do one thing, right? We will select all of them. We don't need method of selection. So whenever we are selecting, it doesn't matter whom we select first or whom we select afterwards. The selection matters, but how we select, the first, second, doesn't matter. Okay, so that's selecting. That's the difference between arranging and selecting. So if I am to write, when we select two out of three, okay, so in the first example we selected two people out of three people, the permutation should be 3p2, right? 6, so it should have been 6 ways, but because the order of those selected two did not matter, we divided it by 2 factorial. Now if you remember, uh, in my previous tutorial I discussed about the words statistics. If you don't know, you can check that out on the top right corner of your screen. The word statistics, the bookkeeper, and appearing. In this, let's say in the word statistics, the s was repeated 3 times, so it did not matter where I put those s in the words. Okay, so 3s were there, then 3t's were there, so these t's were interchangeable, so I divided it, the total arrangement, by 3 factorial. Similarly, s was thrice, so I divided my total arrangement with 3 factorial, and then I was twice, so I divided my total arrangement with 2 factorial. Here I am doing something similar, because it doesn't matter whether r comes first or g comes first or b comes first. I am dividing it by the number of selection values. If I am selecting 2 values, I am dividing my permutation with 2 factorial, because they are interchangeable. So the combination here will be 6 upon 2 factorial 2. The answer will be 3 options. When we select 3 out of 3, the permutation should be 3p36. But because the order of selected 3 things does not matter, it is divided by 3 factorial. So the combination here is 6 upon 3 factorial, which is 6 upon 6, that is 1. So I hope you guys are getting the concept here of combination, that when permuting we just find the arrangements, but at the time of combination the order doesn't matter. So the number of things we are selecting, its factorial is divided, okay, divided from the permuted value. So that will give us the formula of combination. Let's define the combination first and then we will see its formula. Combination: the mathematical method of calculating number of ways r things could be selected from n different things is called combination. So the mathematical method of calculating number of ways that we can select r things out of total n different things is called combination. So here the word selection, the selected, is important. In permutation, arrangement is important. In combination, selection is important. So in short, combination is a mathematical formula of calculating selections. It is denoted as NCR. Because it's combination, it is denoted as NCR. Now, as I just told you guys, that combination is dividing permutations with the r factorial, the selection factorial. So it is simple. NCR is NPR upon r factorial. Now we know that the formula of NPR is n factorial upon n minus r factorial. So just multiply that n minus r factorial with r factorial. So the formula for combination is n factorial divided by n minus r factorial into r factorial. A small addition, multiplying the denominator with r factorial. That's the difference between permutation and combination. So if I just change the side of this r factorial here, I can get something like this. NCR multiplied by r factorial will be NPR. Remember these relationships, because these relationships will be useful for solving 1-mark MCQs and theoretical and short sums. N is the total number of things, R is the number of things to be selected. Okay, so this is your formula for combination. Let's take some examples so that we can understand better how the formula of combination works. Let's take 10C10. So if it is 10C10, it will be 10 factorial divided by 10 minus 10 factorial into 10 factorial. Okay, so this is n minus r and r. So now 10 minus 10 is 0 factorial into 10 factorial. So 10 factorial into 10 factorial will be cancelled. It will be 10 factorial upon 10 factorial, that is 1. So 10C10 is 1. 5C3, that would be 5 factorial upon 5 minus 3 factorial into 3 factorial. So it will be 5 factorial upon 2 factorial into 3 factorial, which will be 5, 4, 3, 2, 1 upon 2 into 1, 3 into 2 into 1. So what I can do here, I can just cancel this out. 3, 2, 1, 3, 2, 1, I can cancel them out. I will be left with 5 into 4 upon 2 into 1, which will be 5 4s are 20 upon 2, that is 10. So 5C3 is 10. Then 6C2. So 6 factorial upon 6 minus 2 factorial into 2 factorial, that is 6 factorial upon 4 factorial into 2 factorial. So that is 6 5, 4 factorial and 4 factorial I will cancel. So 6 into 5 upon 2, that is 30 upon 2, 15. Similarly, 100C3 is 100 factorial upon 100 minus 3 factorial into 3 factorial, which is 100 factorial upon 97 factorial into 3 factorial. That is 100, 99, 98, 97 factorial. I am going to cancel this 97 factorial with this 97 factorial. I will be left with 100, 99, 98 upon 3 factorial, that is 6. So when I solve this, I get 1,61,700. So we can use the methods, the formulas of combination in this manner. Now, before we start with doing the actual sums, let us understand some standard forms of combination. Just like in the permutation, similar standard forms are there for the combination. Let's see how they are given. NC0 is 1, and here is the proof that NC0 is n factorial upon n minus 0 factorial into 0 factorial, which is n factorial upon n factorial, that is 1. NCN is also 1. Now if you remember, NPN was n factorial, but here NCN is 1. Why? Because NCN is n factorial divided by n minus n factorial into again n factorial. So n minus n factorial is 0, but n factorial remains, so n factorial upon n factorial will be 1. Next, NC1 is n. Now this is something similar to permutation. So NC1 is n factorial upon n minus 1 factorial and 1 factorial and n into n minus 1 factorial and n minus 1 factorial. Cancel, n is remaining. But NCn minus 1 is also n. How? So NCn minus 1 is n factorial upon n minus 1 factorial and n minus 1 factorial. Now we know that this just gives us 1. So n factorial upon 1 factorial into n minus 1 factorial is something similar here. Yes, these two are similar. So the answer will be n. If these two are similar, then answers must also be similar. Okay. So here also these two values are similar. So the answers are similar. Then NCR is equal to NCn minus R. Now this is something which was not part of the permutation. This is specifically only applicable for the combination sums. Here it means to say that if we are taking NCR, we can get the same answer by calculating NCn minus R. Let's take an hypothetical example. If I have 10C3, then it will give me the same answer as 10C10 minus 3, that is 10C7. So 10C3 and 10C7 will give me the same answer. These two will get me the same answer. This is what this concept is saying. Let's prove it. First of all, NCR, we know the formula, n factorial upon n minus r factorial into r factorial. Let's see if we get the same formula from this value. Okay. So NCn minus r is n factorial upon n minus r factorial and n minus r factorial. Now this n's will be cancelled, so I will be left with r factorial and n minus r factorial. Now just check these two out. N factorial, n minus r factorial, n minus r factorial, r factorial and r factorial. So that means this is the proof that NCR is equal to NCn minus r. In the next tutorials, when I will be discussing the combination practical sums, at that time we will be applying this method many times. That time I will explain it better. Now the last one is that if NCX is equal to NCY, that means there are two combinations with similar n values but different r values and they are shown as equals, then whether x plus y will be equal to n or x will be equal to y. Now this is again a standard form which you need to remember for your reference. We will be using this in the future sums. So I want you guys to write down all these standard forms and remember that, so that we can use it practically in the sums in the future. Now that would be the end of my today's tutorial. Next time what we will be discussing are the many sums based on combination. Basically we will be discussing sums from the exercise 6.2 and those things we will be doing. So I hope you guys have understood the concept of combination properly. In case of any doubts, you can contact me. If you like what you have learned just now, give me a thumbs up at my video. If you are new, subscribe. And if you have any feedback, then comment below. Thank you very much and I will see you next time. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.